Okay, last day, chapter 20, I believe, and it's recursion. And this whole idea of recursion comes into play, and it's a little bit of a takeoff from something you did in algebra because it looks a lot like a piecewise function. And hi, Tayden. And in the world of teaching teachwise functions, I've always thought that people just do it backwards. Nobody cares and nobody understands. But if you had some data, da 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 da, view. Did you ever get a song stuck in your head? Save a horse, ride a cowboy. If you had a graph, and a lot of algebra is based off of graphs. And if you had a graph that had a bunch of dots and they were like this, and you wanted to predict, ooh, you wanted to predict the future off those dots, you would say, well, that kind of looks like a straight line. And you might, how do I predict the future? Well, kind of draw the line or get the equation and so forth. And then, after linear, you went into quadratic and all these different algebra functions to explain things. But what if I had some data and it's like, oh man, things were taking off really well to a certain point, like, and then COVID hit, and then we quickly dropped at a steady pace, and then what happened after that is this shape, and then you start saying, okay, well, if this is 0 and this is 5 and this was 10, and we got to this point at 15, you would start to say, well, from 0 to 5, how could I, dot, 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 how could I make predictions? And then you would come up with an equation, and then you would just specify it from 0 to 5. So that's where you started to get this piecewise function. And you're doing it from 0 to 5, something happened. 5 from 10, something happened. 10 to 15, and you would be describing this as a function. For example, this second one might be like 5 minus 2r, depending on what's going on here. You'd have these different ways to come up with this piecewise graph. Well, that's how it should be taught, in my opinion. You start with this and come up with this, not here's this, graph this, and it's boring as heck. So give me some real data, and I can work with a piecewise function. Well, a similar format to the way it looks is what you folks did in recursion. And to get ready for today, in recursion, we need to touch on it now because 162, it's coming. And you need to have that pre-talk about what it is so that you're not totally blown away when you get these more in-depth reasons for why to use a recursive function. So here's a recursive function, and we have a domain, and what's happening during that time spell of x. And x's and y's are boring. Yes, everybody, we know x's and y's, but if I did hours down here and cost up here, that might make things a little bit different. But we then change it to x and y because we're used to graphing with x and y. But I still like cost is $50 plus $40 an hour, and it's going to go something like that, starting at 50. Okay, but we're doing x's and y's, and recursive functions aren't so much tying into this graphing part, but it's laid out the same. And that is, I have this domain, this time period, anything less than or equal to 5, I got this, yeah. And what I'm actually doing is I have functions calling themselves, which is the recursion, and some things you should have come up with. This guy on the right is your base case. This guy is the recursive case. And you went through, and can somebody tell me what the answer is to what is f of 20? Now, hopefully you're going, yeah, I watched the videos. I think I have a decent idea of how to do this, and I can calculate f of 20. No? I'm going to go slow, let some of you take off. My x value is 20. It is greater than 5. So I'm going to use this case right here. And I'm going to say, well, f of 20 is going to equal f of 16 plus 1. Do I have a problem? Yeah, because I don't know what f of 16 is. So I'm starting to go down this rabbit hole until I hit a stopping point and then back my way out. Yeah, recursion. I have a function that calls itself. I should write that down. A function that calls itself. I mean, I'm tying in function notation with a term we use. Huh? How about that? Back at the ranch, f of 16 equals f of 12 plus 1. If somebody has worked ahead and has an answer, feel free to shout it out. Feel
Ends up
free.
being 6.
You say 6? Okay.
That's what I have.
Right, I have a good guess at 6. Good guess at 6. Well, let's see. I still need f of 12, and that's going to be f of 8 plus 1 because I take the 12 minus 4 and get the 8. But now I'm going, well, shoot, I don't know what f of 8 is. I'm still greater than 5, so I need to find f of 4. And yeah, I don't know what f of 4. Oh, no, wait. F of 4 is 2. So this is 2 in place of f of 4. And if I add 1, I get 3, which is my f of 8. And if I put it up here and add 1, I get 4. So that's f of 12. Here's a 4, and that gives me 5. And I think I'm happy with that answer of 6. Nicely done, Jacob. So I kept doing the recursive case, until I got down to the base case. And this is the easiest way to start out learning it, going with these functions. In my CPS 230 class, we do a bunch of these as extra topics so that you get really good at it. The reason I include recursion is because some students just take 121 and 230. They want to get a Java background and move on. Yo, boy. G of x equals g of x plus 5 plus g of x plus 8. And then we got if x is even and positive, okay, or if x is odd and positive. So the negatives hit the recursive case. This time I have 2 base cases. Could go down 2 rabbit holes. How about that? Watch me do that. Reminding me of the default case for a switch statement. It's just the person I thought of. Yeah, I could see that. It was a stopping place if nothing else was working. All right. So they're working. So while they're working, I'm going to say negative 10 is this first case. So that's a g of negative 5 plus g of negative 2. Huh. G of negative 5. That's this first case. So that's going to equal g of 0 plus g of, let's see, negative positive 3. Okay. Oh boy. Staying over here, I got that sum. G of 0, oh boy, equals G of -5 plus G of 8. G of -5. Oh my goodness. Oh, I'm going to find that in a minute. In a minute, I'm going to need a G of -5. What's G of 8? It's even and positive, so that's going to be 2. G of -5, I don't know yet, right? So I can't even put it in there until I find G of Z. Oh boy, G of 3. Uh-oh, I may be in trouble here. G of 3 equals odd and positive -1. So that's going to be a -1. But I think I have a problem with this one. I can't find G of 0 because I need G of -5. And I can't find G of -5 because I need G of 0. So let's double check. -10 and 5 is -5. -10 and 8 is -2. -5 if I put in is G of 0 and G of 3. G of 0 is going to be G of, oh, I messed that up, didn't I?
+5.
+5. This is known as checking your work. What is G of +5?
-1.
-1. So that's going to be a -1, which makes this a +1. So now I know G of 0 is +1. When I add it there, I get 0. G of -5 is 0. Yeah, and I need G of -2, not something I found already. Anybody get a final answer yet?
Mine came out as 1. I don't know if it was right.
I hear 1. Anybody kind of get a hell yeah from a redneck girl? No? Plug in -2. That becomes G of 3. Plug in -2. That becomes G of 6. G of 3 is going to be -1. G of 6 looks like that's 2. So -1 plus 2 equals +1. So -2 is +1 equals 1. Yeah, we got the answer. Woo woo! Got the answer. Uh, what would the function look like? What would the function look like? For this first one, I got this guy up here. How would I write the function? You want to call the function? Want to just call it f? Yeah. Let's see. I have an int f of. I'm bringing a value in. We'll make sure that's an int as well. Now, this is kind of pseudocode. I know I need a return type, and I know I need a parameter coming in. So here's my if. If x is greater than 5, what do I do?
Call the f function again, subtracting 4 from x and then adding 1.
Okay, I'm going to call it again, subtracting 4 from x and adding 1. But what do I put right here? This is going to be a return statement. Yeah, very good. Thanks, Zach. That's it. That's it. Remember how we went down the rabbit hole? So when I get ready to return this, it's going to go find out f of 4 first and add 1. Whoever came up with these languages and made a compiler understand just blows my mind. It's just crazy. But there you go. Hey, that's not too shabby, is it? Kind of looks easier than I thought. What about this one? The second one. What do we have? We have int. We said f of int x. And then we went if x was greater than 5, return f of x minus 4 plus 1, else return 2. Okay. All right, all right, all right. What do you think about that second one? Let's see. I'm just simply going to call this function g. I'm going to stick with ints. Int g of int x. Somebody give me the start.
If x divided by 2 equals 0.
Let's start at the top and go down.
Okay.
Okay?
Return g.
Because yeah. If x is less than or equal to 0, return just what's there, right?
G. X
Yeah.
plus 5 plus gx plus 8.
Yeah. Else, if
X modulo 0 or x modulo 2.
x mod 2, what about it?
Equals 0.
Equals 0, what do we have?
Return 2.
Okay, what about the positive part? Or the even and positive? Do I need to do an and? I didn't do very good with my modulus. Wow, I even wrote the word mod. Goodness gracious. X mod 2. Pseudocode. See how I did that? Pseudocode. Do I need to check to see if it's positive?
Yes,
Why?
because it has to be a positive number.
What else could it be? Talk to me, Hunter. Keep going.
I mean, it could be a negative number.
But then we take care of all the negatives already.
Yep.
Yeah.
So we're defaulting out that we took care of the negatives. So if it is negative, it's not getting this far. So I could actually stop there and say return 2. Okay. I cleaned it out. I cleaned all the negatives out. Good. And then finally, else,
Return -1.
yeah, by default, we already took care of the negatives, we already took care of the evens, and that kind of code would work. It's kind of cool. I don't know. I think it's kind of cool. Could this have been done with while loops?
Sure.
Yeah. Yep. It can. It can. All righty. Oh my. Oh my. But you're going to do the rest of the class. Now, would I recommend doing it by hand first to make sure you get the right answer? Yes. Is the coding part of it going to be too hard? I think it comes kind of out straightforward. Sometimes I'll have a second function, a G function, defined, and they could cross back and forth and so forth. But if I'm starting on this, f of 10, 6 equals, what does f of 10, 6 become? It becomes f of
Nine.
Go ahead.
9, comma 6.
Yep. Yeah. Notice the X's and Y's are switched here. It gets kind of goofy later. And then here's my base case. All right. Once X gets down into the negatives, I'm going to use that as a base case. So I'm going to put you in groups. I want you to do it by hand so you have an answer, and then code it and see what you come up with. Once you get it, give me a holler and I'll come in and check it out. Otherwise, ba-deep. That's all, folks.
Okay.
You survived my 161 class. Well, maybe.